go. I'm not going to go through that again. You can do that on your own if you want to try it. But I did try the 2 as a root. Let's see if I can get the cap off. Here we go. So I did try the 2 as a root, and it worked. Okay, so let's go ahead and just copy down the coefficients again for our synthetic division. And we get 3, -10, 10, -4. I got a little handy dandy chart there with 2 as a possible root. All right, and then we'll just go through it and I'll show you that it works. Drop the 3, multiply, 2 times 3 is 6, add -4, multiply by the possible root, and you get 2 times -4, which is -8, add, you get 2, multiply it by the possible root, 2 times 2 is 4. When you add these, you get a 0. That checks out. Yay, we're very, very happy because that means the 2 created a 0, no remainder, so 2 is a 0 or a root. Okay, so that means what we're left with here, if 2 is a root, then its factor would be x minus 2, right? That would be the factor. And then the remainder of the equation after we've divided it. So we have a 3, sorry, that's a 3, I don't know, that didn't look like a very good 3. So 3x squared minus 4x plus 2, that's my other factor. So this original polynomial of degree 3 right here has now been broken down into this, into 2 factors. X minus 2, because we discovered that 2 is a root or a 0, and then the remaining factor would just be this, the 3x squared minus 4x plus 2, and that equals 0. Okay, well, we're good. We already know one of the roots is 2, and that's the original direction. It's saying solve the equation by finding all roots. So we know 2 is a root. I just put it back in factor form. So now all we have to do is solve this, right? And find its factors. Well, it just so happens that it doesn't factor very well at all. So we're going to have to use quadratic formula, all right? So remember quadratic formula? To find x, it's the opposite of b, plus or minus, taking the square root of b squared minus 4ac all over 2